Ben.
Okay, this is something that is not an AP topic. However, we have a little bit of flexibility with time in this class. And many of you are going to go on and go into careers that involve mathematics. How many of you want to major in something where you're going to have to take mathematics beyond Calculus 2? Okay. Differential equations is a very popular class for somebody to take who is maybe like an engineering major or a math major. Okay, so I want to give you just a little bit of taste of what you're going to see in differential equations. Like this is itty bitty taste. Okay, this is one section. Okay, so we talked about a couple days ago. Yes.
Are we doing the entire class today?
No. We talked a couple days ago about separable differential equations where we put y's on one side and x's on the other side. Well, that's not always a possibility. Okay? Specifically, we are going to look at first order linear differential equations that have this form. Okay? Or maybe there's an addition involved to where we can't separate out the x's and the y's. But if it follows this particular form, then we can be a little bit creative in our math and use some knowledge from before to help us get to a point to where we can find the solution using calculus instead of just a slope field. Okay? Because there are some times where we had to only look at a slope field in order to look at the solutions to a differential equations because we couldn't do separation of variables. So now we are going to have this one specific setup that we can do. So P and Q are continuous. That is important. If they're not continuous, this isn't going to work. Okay? But if you have dy dx plus some sort of function of x times y equals some sort of function of x, then we can consider that a first order linear differential equation. That's a lot to say. I know. Ugh. It's like a tongue twister. Okay. So we are going to choose what we call an integrating factor. Okay? And I would write this down. All right, we're going to choose an integrating factor. We're going to call it u of x. And we're going to choose u of x so that u of x times p of x equals u prime of x. I'll show you how to choose it, but I'm telling you that this is what it needs to look like in the end. Okay, so this is our standard form. Write it down. I'm going to go through the math of like the rhyme and reason behind what u of x is and where it goes and why this all works. But then once we go through kind of the why, then we can just do it. Okay? Kind of like on Monday when I wasn't here to tell you, we're just going through the why of how we get to lice minus licked, but then now here it is, let's just do it. Okay? All right, so I am going to multiply everything by our integrating factor. Okay? So we have u of x times dy dx plus p of x times y times u of x equals q of x times our integrating factor. Okay. Okay, well, I told you that we are going to pick a integrating factor specifically so that u of x times p of x is u prime of x. Okay, well I see p of x times u of x, don't you? Commutative property, but I see it. So I'm going to go ahead and change this to be u of x times dy dx plus p of x times u of x is u prime of x times y equals q of x, u of x. Okay. Look at that left side. Does anything look familiar about it? I see u of x times dy dx plus u prime of x times y.
That's like when you do the derivative of two things multiplying together.
Whoa, that's like the product rule, isn't it?
Yeah.
What is it the product rule of?
U of x times y.
So this means, so this is the product rule from when we take the derivative of u of x times y, right? Okay. So once we get that integrating factor and we force this product rule to happen, well, now we have a derivative over here where we can just integrate both sides to where now we're dealing with u of x times y equals the integral of, I don't know why I threw in parentheses there, q of x, u of x, dx. And now, can we solve for y if we wanted to?
Sure can.
Okay. Okay. Now, I've showed you the benefit of having an integrating factor and what it does for our differential equation. But how do we choose it? What does it mean? Or like how does it all work together? So let's go back to our integrating factor. Okay? U of x times p of x equals u prime of x. Okay? I want to know how to figure out our integrating factor. Okay? U of x just doesn't fall from the sky, which it did. But we actually have to figure out what our integrating factor is and how we can force that product rule to happen. So let's rewrite this, shall we?
Sure.
Are you okay with my rearrangement where I divide the u of x over to be with u prime? All right. What does that look like? The derivative of the natural log of, not just something, u of x. So, this is the derivative of the natural log of u of x. Is this like,
and I spend way too much time on
Yes,
this.
me.
I swear.
These are things you do when you're a mathematician. Okay? Alright. You're gonna do an integral?
Oh yeah.
Okay.
Always.
So we have the natural log of u of x plus c over here equals the integral of p of x dx. Are you okay with the plus c? Somebody said what?
Why wasn't there a plus c with the u of x times the y?
Over here?
Yeah, that.
We could say plus c. However, we're going to do this over here and get a plus c. So it'll even out. Does that make sense?
Yeah.
Okay. Over here, it's not, we just, trust me. Okay. How do I solve, we want to know what u of x is. Okay? Right? Okay. I'm going to do this so that we can exponentiate both sides. So u of x, we know that e to something plus c is going to end up being something like this. Where did I lose you?
Would that be a minus c?
Minus c plus c, it's just a constant. I mean, it's, yes, it is.
Right.
It is a minus c. Well, how about I do this? Now, do you feel better?
Yes.
Now, what happens when we substitute in our integrating factor over here? Or when we multiply by our integrating factor and we do all of our work, this constant is going to end up being irrelevant. Okay, it doesn't matter. So we can just go ahead and say that our integrating factor is e to the integral of p of x dx. Yes.
Where did you get the dx?
When we integrated both sides. So here in the green I had this, and then I wanted to integrate both sides, so I had to throw on a dx for our integral to say that we're doing it with respect to x. Okay. Other questions?
So
Yes.
You have to integrate both sides at the same time. You can't
Yes.
just do one side.
Yes. Well, just like adding 5 to one side, we're going to add it to the other side. Yep, we have to integrate both sides at the same time. Make a derivative of both sides at the same time. Since we're talking about an equation. Okay. All right, so here are your steps. Are you ready?
It's an e because there's an idea. Like, are you
Yeah.
sure?
I'm on the same page as
Are you positive? There's an e there.
Your first step.
Yeah.
Write it in standard form if it isn't already.
you.
Step 2. Identify your integrating factor by using u of x equals e to the integral of p of x dx. like we did in the beginning, when I showed you why this is going to work, we're going to multiply our entire standard form by u of x. You should see that product rule happening. So I'm going to ask that you rewrite your product rule so that you can integrate and solve for y. Okay. So when you see a differential equation, you do need to ask yourself, can I separate variables? And if not, is it in this first order linear differential standard form, or can I get it there? Okay, so you have two types of differential equations that you are capable of solving. Separable, and now first order, linear. Well, let's get a little bit of practice under our belt. Write it down. Okay, first of all, is this separable?
No.
No. Okay, would this be considered standard form? We need dy dx plus something, don't we?
Yeah.
Okay, so what's bothering us?
X is
X. So I need to divide everything by x so that we can have dy dx by itself minus two over xy equals x. Now, technically, is this in standard form yet?
no.
There's no addition.
It's supposed to be addition. There. Easy fix. Okay. Whatever is being multiplied by y, what do we call that?
P of x.
Okay. And p of x is what helps us find our integrating factor, isn't it? Okay. So here's step one, right? Step two, let's find our integrating factor. So our integrating factor is e to the integral of p of x dx. Well, what's the antiderivative of negative 2 over x?
Negative 2 natural log of x. So value of x.
Here is where your algebra really needs to come into play. Because if you can cancel out the e in the natural log, it's going to go a lot better for you. Okay, is there a way for us to rearrange so that we can get rid of the e in natural log?
Is it like x to the 1/2? Yes.
It becomes the exponent, and so e and natural log undo each other, right? Okay. Yeah, not so bad, right? So now, step 3. We need to take our first order linear, I'm trying to say it, standard form, and multiply it by our integrating factor. I'm going to call our integrating factor 1 over x squared. I feel like I'm going to be a lot more successful, me, personally, if I write it that way. So we get 1 over x squared times dy dx minus 2 over x cubed times y equals 1 over x. Okay. Every time, right here should look like a product rule. Do you recognize it?
Yes.
Okay. It is the product rule of which two functions?
U of x and y.
U of x and y. Okay. So now our fifth step is to integrate both sides. Okay. And the integral of a derivative goes away. The integral of 1 over x dash the log of x plus c. Look, guys. Look.
We did it.
We can solve for y. We can multiply x squared over and we have a general solution to our differential equation. And as much setup as we did in the beginning of class, the steps really aren't that bad, but I need you to understand where all the math is coming from. Caleb.
Should we leave it like that, or can we distribute the x squared?
It doesn't matter. You can do either way. Okay. It's not going to bother me. All right. Do another one?
Sure.
So,
I hear like, eh.
we
have-
You have two more slides. You have 2 more slides. Might as well.
Do I have 2 more? One's your homework one. Which? I need to give some people their book codes today. I will be doing it on my books. Yeah, you told me yours still works. And Nick still works. Okay, so what should we do?
I'm confused.
What?
Already. Can't you just like separate those? Because it's plus 0.
Well, first we have to like add the dy, right?
Yeah, it should just be dy.
And then divide by dx. Caleb says
Can't
when
you
we-
just like separate them and divide by y plus 1 and then do the integral of that?
Can we?
Can you not do that? What's wrong? I'm confused.
No, it is separable.
Oh, okay. I was like, already.
However, okay, and is separating variables going to be shorter?
Yes.
Okay. But for practice,
Not do it.
Of course. Okay.
Okay, what I was really hoping would happen is that you would like blindly just follow me.
Yep.
And
Oh, I
not,
ruined it.
no, you didn't ruin it. Like I wanted somebody to say it, okay? Because if it is separable, then that's going to be the better option.
You heard it here.
Okay.
Stop recording.
You gotta put the Caleb trademark. Gotta
love
separate.
the
You gotta
kid.
separate. You gotta separate and give it like.
Yeah,
Just so he knows.
Caleb skepticism. Gotta try to spell his last name.
Oh,
I was gonna give like a thumbs up.
That's not.
That's close.
That's pretty good.
That's pretty
Gotta
close.
say.
Think
I don't
thumbs
think
is
Benjamin can see the shadow.
Well, maybe it's jammed. Okay. So let's go ahead and just to practice this process, let's make it into a first order linear differential equation, knowing that yes, we could separate it, and maybe when we're done, we should do separation of variables and just make sure we get the same answer.
Can you do that on the quizzes and tests so we can check our work?
Probably not gonna do that.
Oh.
Okay. So we would have dy dx plus negative cosine of x y equals cosine of x. That would be our standard form. How did I get that?
Algebra. Maybe
Oh yeah, the distributive property.
Whoa. Whoa. Okay, I see that.
So cosine of x stays, and y cosine of x gets subtracted over. But we don't want subtraction, we want addition, so I change it to plus a negative cosine of xy. Richard, do you have a question? Okay. Just seeking in. Okay. Whatever is being multiplied times y is your p of x. Please remember that. And keep in mind that we want addition, so if there is a negative sign, you need to account for that in your p of x. So our integrating factor, u of x, is going to be e integral negative cosine of x dx, which would be e to the, I hear two different answers,
negative sign
negative sine of x.
plus C.
Oh, we don't need to worry about it.
Times K. You just
Because once we substitute it in, it's all going to cancel out, so.
Oh
You said
Is that like Kool-Aid Man back there?
yeah. Most definitely.
Okay.
Who doesn't just occasionally Kool-Aid Man? Oh yeah. That's
I multiplied everything from our standard form by our integrating factor. And you are always looking right here for the
Product rule.
product rule. What I underlined in green is the derivative of e to the negative sine of x times y. Yes or no?
C.
Check it. Whatever you have right here.
That's aggressive.
Well, I'm just saying, you want your work to be nice, right? You want it to work out, right?
Yes.
Whatever you have right here, take the derivative. Is that what you have right here? Get a lot of flack for being passionate about my teaching.
We learned in psychology that it actually helps you remember. So.
Okay.
You missed Ailey. He said you can be really angry at him now because it helps you remember. So you can just be like super angry in
and
class.
happiness
Always angry at
trigger.
Yeah.
No, that's fair. Just bring
Okay.
Bring it back.
Integral of a derivative goes away. And how will I perform this integration over here?
Please don't tell me you have to do U substitution.
What if you really feel like
No.
It's
Oh,
just
my
the
dog.
negative side. It's
People like,
What does U need to be?
my name. What is your name?
Sine of x, du, cosine of x. So we really just have e to the negative u du. Is that bad? It's not that bad.
Right there.
So we end up with negative e to the negative u. Then, carefully, we're going to divide this over. To get y equals 1 plus c e to the sine x. That s is in the exponent, sir.
What happened to the negative? That just disappeared too.
Think about it.
It was on the bottom.
It was in the denominator.
But no, it's
But it's negative e to the
Oh.
negative side.
-1
Plus
plus.
you flip
Yeah,
it over.
yeah, it needs to be -1.
Oh, that one.
Checking.
Yeah. Oh, yes.
Right.
Check it. And then
Okay. So this is fun. Do you want to do the separation?
I trust you.
I did it. It checks out.
Checks out.
We trust
Well,
Nick.
as long as Nick says it checks out, it must.